Hello everyone, in this video let us solve this equation. So we have 2 raised to power t is equal to t raised to power 32, and here we have to solve for the possible values of t. So t is equal to question mark. Now to do this, solution. So we have 2 raised to power t is equal to t raised to power 32. Now the first thing we're going to do is to eliminate this t right here. And to do so, we're going to multiply the both side of the equation with power 1 over t. So this becomes, in bracket, 2 raised to power t, all multiplied by power 1 over t, is equal to, in bracket, t raised to power 32, all multiplied by power 1 over t. And with this, applying the rule that if you have a raised to power b or power of c, this equals a raised to power b times c. Applying this rule right here and here also, we have it to be equal to 2 raised to power t multiplies power 1 over t. T times 1 is t all over t is equal to, we have t, now power 32 multiply 1 over t. 1 times 32 is equal to 32 all over t. And from here, simplifying this further, 2 power t cancel power t, and this is then equal to, we have t raised to power 32 all over t. So with this, the next thing for us to do is to eliminate 32 from here. And to do so, we're going to multiply the both side of the equation with power 1 over 32. So this becomes, we have 2 raised to power 1 over 32 is equal to, in bracket, t raised to power 32 over t, then multiply it with power 1 over 32. Just that this is then equal to, applying this formula, that if you have, in bracket, a raised to power b or power of c, this equals a raised to power b times c. Applying this right here, we have it that 2 raised to power 1 over 32 is then equal to t. Now power 32 over t multiplies 1 over 32. 32 times 1 is 32 all over t times 32 is 32t. And from here, the value is 2 raised to power 1 over 32 equals t raised to power 32 counts to 32, we have 1 over t. Now looking at the right hand side of the equation, we have it that the base right here equals the power denominator. So, but on the left hand side, the base right here is not equal to the power denominator. And for us to simplify this, we need to make sure that the base here equals the power denominator. So how do we go about it? So we are going to make use of the concept of equivalent fraction. Now, it simply means that if you have 2 over 2, this 2 over 2 can be written as 3 over 3, because 2 will divide 2, we have 1, 3 will divide 3, you also have 1. And this one can also be written as 4 over 4. Okay. Now, also, if you have 1 over 2, 1 over 2 can be written as 2 over 4, because 2 will divide 4, you have 1 over 2. So, with respect to this, we are going to simplify this just that we make use of equivalent fraction. And to do so, we can make use of it this way. First, we are going to factorize power 1 from 1 over 32 right here. This becomes, we have 2, then factorize out power 1 from here. 1 times, we have 1 over 32 is equal to t raised to power 1 over t. Now, the concept of equivalent fraction will be applied right to this power 1 right here. Now, we can replace power 1 with 2 over 2, such that this is then equal to, we have it 2 raised to power 1 becomes 2 over 2, then times 1 over 32 is equal to t raised to power 1 over t. And from here, multiplying the powers, 2 raised to power 2 times 1 is 2 over 2 times 32 is equal to 64, and this is equal to t raised to power 1 over t. We're going to factorize out 2 from here, such that this is equal to, we have 2, then factorize out power 2 from here, so 2 times 1 over 64. If you multiply 2 times this, you will still get 2 over 64, and this is equal to t raised to power 1 over t. So from here, applying the rule of indices, that if you have a raised to power b times c, this is equal to a raised to power b or power of c. So applying this right here, what we then have is that we have it as 2 all raised to power 2, then power of 1 over 64, and this is equal to t raised to power 1 over t. From here, 2 squared is 4, so 4 raised to power 1 over 64 is equal to t raised to power 1 over t. So with this, looking at this, the base right here is not equal to the power denominator. So we are still going to simplify this further by making use of equivalent fraction. Now in this case, 1 over 64 can be written as 2 over 128, because if 2 divided 128, we have 1 over 64. So we can bring in 2 over 128 to replace 1 over 64. And this is then equal to, we have 4 raised to power 1 over 64 becomes 2 over 128 is equal to, we have t raised to power 1 over t. Shows that at this junction, factorize out power 2 from here, so this becomes 4 raised to power 2 times 1 over 128 is equal to t raised to power 1 over t. And then applying this rule of indices, if you have a raised to power b times c is equals, in bracket, a raised to power b power of c. Applying this right here, this becomes, in bracket, 4 raised to power 2 all multiplied by power 1 over 128 is equal to t raised to power 1 over t. And from here, 4 squared is equal to 16 raised to power 1 over 128 is equal to t raised to power 1 over t. Now looking at this, we have not yet achieved the goal. The base right here is not still equal to the power denominator right here. So we are still going to apply the equivalent fraction. But in this case, 1 over 128 can be written as 2 over 256, because 2 will divide 256, you have 1 over 128. So in the place of this, you can bring in 2 over 256. So this becomes, we have it to be equal to 16 all raised to power 2 over 256 is equal to t raised to power 1 over t. From here, factorize out power 2, so 16 raised to power 2 times 1 over 256 is equal to t raised to power 1 over t. And also, applying the indices rule, that if you have a raised to power b times c is equals, in bracket, a raised to power b power of c. Applying this rule right here, this becomes, in brackets, 16 raised to power 2 power of 1 over 256 is equal to t raised to power 1 over t. And from here, 16 squared is 256, then all raised to power 1 over 256 is equal to t raised to power 1 over t. Now looking at this, we have achieved what we wanted to achieve. We have made the base right here to equal the power denominator right here. Same thing also on the right hand side, the base is equal to the power denominator. So with this, right, we can then compare the exponents, shows that 1 over 256 is then equal to 1 over t. So simply cross multiply, t times 1 is t equals 1 times 256 is 256, and this is the value for t equals to 256. Good. Now with this, we've gotten the value of t, but then let us confirm if the value of t that we got is the correct solution. So back to the question, let's check it out. The question is 2 raised to power t is equal to t raised to power 32. Now the value of t is 256, so inputting the value of t into the equation, 2 raised to power 256 is equal to t is 256 raised to power 32. So with this equal question mark. And from here, 2 raised to power 256 is equal to, don't forget that 256 is equal to 16 squared. So inputting this becomes 16 squared raised to power 32. And from here, power 2 multiplies power 32. This will be equal to, we have 2 raised to power 256 is equal to 16. Now 2 times 32 is 64. And from here, recall that 16 is equal to 2 raised to power 4. So in replace of 16, we'll bring in 2 raised to the power 4. This becomes 2 raised to the power 256 is equal to 16 becomes in bracket 2 raised to the power 4 or power of 64. And from here, right, the value is 2 raised to the power 256 is equal to 2 raised to the power 4 times 64 is 256. And this, right, is the correct solution. So that means that the value of t that we got as 256 is the correct answer that will satisfy the given question. So with this, ladies and gentlemen, we've come to the end of this video. Don't forget to subscribe to this channel, share this video to your friend. Thanks for watching. See you in the next video. Bye.